So I'm going now to start the lecture. Let's try to share my screen. By the way, please, when I am asked a question, because since here right now I cannot see your face, so one of you just volunteered, said yes, I am here, or clear, or there is no problem, or there is a problem. I don't know. When no one say anything, I thought sometimes I'm just speak with myself. Of course, if someone pass from outside, it's how that I'm speak with myself. But for the other who didn't install or who didn't find yet, I'm going to share you lots of things. Actually, I'm trying to record the things from last semester. I'm just record the installation process. But since the file is a web record, I don't know how can I do it in Adobe Premiere and make it in a correct way. Okay, we try to show it for you, and don't worry about the installation process. We are going, I am a very flexible person, maybe some of you know it, especially in such a semester. Don't worry, any time of the day, if you just tell me, we can figure it out, these kind of things. Don't worry about this. So I hope I can find how can I share the desktop from here. Yes, here we go. Let's say this one. So can you see desktop? Is it clear?
Yes, hocam.
Okay, here we go. So some of you ask about the program, how we can find it. Actually, I have a staff website since 2015 when I am starting EMU. That time I was in another department. I was working in civil engineering and construction department. So if you just go here, staff.emu.edu.tr, that's all. You need to find K under my name is Kamiar Fulatlu. Here, when you just click here, just under the teaching or dersler, you come here, it's Arch 383. So here I put our course outline. You can read and go over it about the time schedule, about the assessment criteria. We don't have an exam at all. We just have a classwork and homework, and we have a final project, and we have participation. That's all you can read. And if you have a question or if you have any disagreement, you can tell me, we will solve it. So we need a WinRAR 5.6. You need to just click on it. It's going to download as a zip. There is a password for it. It is Arch383. If you have WinRAR already in your computer, you don't need to download it. But if you don't have, please use it. By the way, the crack of this program, you know that all the crack is catched by a defender of the Windows. When you just download it, don't worry, there is no virus inside of it. This is a crack of the program, because in the crack they are use a virus code, so that's why it's recognized as a virus. So we need S3 ArcGIS or any one that you download and you don't have a problem with that. It doesn't matter. You just go here. It is in my Google Drive. Let's see if it is open or not. It is a RAR file. You need to just press a download. Like here, it is 819 megabyte. Then you just say download anyway, and it start to download. As you can see, I can just press save, and since I don't want to let's say use my traffic band, I'm just cancel it right now. This is till now about the S3. We use also this one called AnyDesk. I don't know any of you use it before or maybe hear it, because last semester, since we have problem, we are start to use the Any. You can also find it from a Google. If you just write AnyDesk, if you just go here, it is available for Mac OS, Android, iOS. Linux, Debian, Raspberry Pi, or Chrome OS. So there is no worry about this. When you just download it,
Yes.
okay.
Yes,
So, okay, thank you. So, this is only the lecture that we will have. Where should I put this one? I don't know. Let's leave it here. So, and it is a easy things. Maybe all of you know these things. Maybe it is funny for some of you. Let's see. So, as I said, the main aim of this course, we are going to provide you a very, let's say, introduction, but of course it is, I try to keep it comprehensive about the geographical information system, or from now on is GIS. At the end of this course, you are able to do many things. You first understand what is basic structure, concept, theory of the GIS. And you are able to do a hands-on experience in a variety of the GIS operation. Of course, it's need your effort too. You are going to understand the component type of the GIS, how the GIS shape, how you can figure it out, how you can add a model or different things. And you will be able to learn what is coordination, what is a projection, how a map can be coordinated or how it's able to project it. And you are going to implement a project in a GIS. You are able to analyze, you are able to understand, present, and give a decision support system. Even you can give an idea. So it is not about only architecture. Architecture just a small part of the GIS world. We have many, let's say, user of the GIS in, let's say, planning, in the police, in a hospital, in a land inventory, everywhere, forestry department, everywhere that you can just think about the crime, about the military, everywhere you can use GIS. It is not only about architecture. I think we almost give this course for since 2000, if I'm not wrong, 2013. Before was Jankara. He gave this course, but right now, since 2015, I gave this course as a Turkish and as a English for a department of the architecture, for a construction, and the committee of the missing person in Cyprus. So, if we just pass here, we need to learn, first of all, what is data and how it becomes information. What is the information system, and accordingly, what is a GIS? And we need to learn application and advantage, and also the component of the modern GIS. The GIS itself, actually, we are coming to the history of it by 1960. Actually, is the start, but nowadays it's become very modern. So let's start with some definition. As I tell you, data. Data is look like this 17. You don't know what is it. When you just look at it, what is 17? Is it 70, let's say, kilogram, 70 people, 70 girls, 70 boy, 70 computer, or 70 centigrade this morning, let's say Famagusta. So if someone says 17, it's not understandable for any of you. But in order to make it as information, you need to put some things at the end of it to make it as an information, like 17 centigrade. That time it means that I need to put my jacket and keep myself warm when I go outside. So it means that the data is a set of value. It can be qualitative or it can be quantitative variable. It can be fact, it can be a number, it can be a word, it can be image, measure, or any set of variable. It doesn't matter. It is a data. It is a raw, let's say, fact or value. When you just see it or when you just hear, you cannot understand what is it. It is meaningless for you. So after we do some operational need, or let's say do some progress on it, we make information like this one. It is, let's say, 17 centigrade or centimeter, kilogram, or whatsoever. So by this definition, we are now going to the information system. First of all, what is a system? When we talk about a system it includes a fragment or component that work with each other for a specific target. For instance, we are a system. Me and all of you together, we are making a system. What is our system? First of all, we have member. We have 10 people here, including me, it's 11. We have an aim, we have a target, we work together. So it is a system. So any system have a member and target. Our body is a system. But when we come into the information system, is a system of the person that data, records, and activity can be processed on it. And we just give you information at the end in a very organization manner. It is most of the time, especially in a computer base, is an automatic system. Actually, our body also automatic. When you just start to drink something, it's work automatically and it's go to your body and through your blood, go to the other member of your body. So why we need it? Why we need it? Look at this map that I put it here. This is an information system. This is done by GIS. This is done by GIS actually. So it tell you the situation or number of the, let's say, confirmed case in a whole world. So by look at this map, you will understand that which zone is a dangerous. So you start to make a decision. Actually, this map help you to support your decision. So it means that we need a GIS for decision support system or DSS. So we need to support in order to solve our problem. So we start to compile this map and we see, oh, okay, Iran have most of the case, it is small, but it is red. Or let's say China, it's big in comparison to the Iran, but it's red still. So you are still to, or you say, oh, Greenland, there is no case, or let's say maximum 100 case there. It is not dangerous. So accordingly, you start to compile the document and support your decision. So all of you use decision system every day. For instance, when you just go to the street, when you want to cross the street, you just looking your surrounding, looking, oh, there's a car coming. You start to calculate in your mind, the car speed is low or high, so can I cross the street on time or not? This is a decision system. You, in your mind, you start to do it. Or about the food, you want to take some food. You say to your friend, this restaurant is not good. So you support your decision and your friend say, okay, let's go to the next block or grab that food there. So that system, it is used by you every day, but in an automatic manner in a word, we are going to use it in a very, let's say, interactive base, or in very, let's say, conceptual base, meaning we are going to see it from other vision. So is there any question up to now about the data information system decision? I think it's very easy things. Any question up to now? Hello?
No, I don't think there's any.
Okay. Please, if I ask just one of you, if there's a question, say yes, or if it's not, not. So, in a very, let's say, brief, we can say geographical information system, or GIS. Geographical, we know that it's a spatial data, we have a coordination, we have a meridian, equator, we have prime meridian or prime equator, we have a null island which is located over here. We have information such as database or data set, access SQL Server, DBase, Oracle, Excel. Actually, we are going to use DBase. And we have a system. It can be a computer network, iPad, cloud, whatsoever. So this is very simple, let's say, definition of the GIS. But let's go to the history of GIS. The geographical information, as I told you, is start by end of the 16 or beginning of the 70. Almost, we can say right now it is 2020. Almost half century we are going to work with GIS. It is first time, let's say, the concept developed by Roger Tomlinson, is known as the father of the GIS. His work in Ottawa, in Canada, by a federal department of forestry and rural development. He invented this system to store, analyze, and manipulate the data which is collected for Canada land inventory. So this is, it means this one itself, the use for store, analyze, manipulate, and collection of the data, it means the GIS definition. We will come into that, don't worry. So Tomlinson also believed that the common ground between information process and many field using spatial analyze technique. So this is right about it. So, but when we come to the GIS definition, there are thousands of the definition you can find. There are a bunch of definition, but all of this definition are unique in this word, these 5 words: collecting, storing, retrieving, transforming, and display a spatial data. So we can say that GIS is a powerful set of tools which we'll use for capturing the data or collecting the data. Then after we capture or collect, we need to store them. We need to put them somewhere. So storing or storage. After that, we need to call them. We need to retrieve them. For instance, we need to ask those data from a storage. And after that, we need to analyze on it. We need to work on it. And at the end, we need to give a result or output. So what we can say, GIS is a powerful tools for capturing 1, storage 2, retrieve 3, analyze 4, and display the spatial data. This is a good definition. So why we use it? To support a decision system in order to solve different problems. So any of them, it can, any of this definition you like, you can choose that one. Since we are not having any exams, so we don't need to worry about it, but it's very easy, don't worry at all. So these are other definitions. You can find many definitions inside the internet also. But as I said, all of them are similar to each other. And this is the reference of them. So, as I said, a very good definition could be like this. This is the ones that I'm finally create. A system of the which is integrated by computer-based tools for end-to-end process include capture, storage, retrieval, analyze, and display. So, of a data using a location on the Earth's surface in relation to the support of operation management, decision market, and science. So this is another definition that I try to give you here. These are all about the GIS definition and literature review of it. You don't need to worry about it. But if we come to architecture, again, same as the definition. First of all, you need to get some data. Let's make you understandable in that way. For instance, again, for site analysis. What you are doing for a site analysis, first of all, you go to the site. Start to collect the data. For instance, how many buildings we have, which one is 2-floor, which one is 5-floor, which one is residential, which one is retail, which one is let's say governmental building, or which one is a public utility, etc. and etc. So this is your data collection. So during this process, you start to store them. Most of you have a paper or a map or let's say whatsoever. You just start to write. For instance, you say building number 1 is a residential 5-floor. It is a reinforced concrete, or etc. like this. So it means that you store your data. After that, you start to retrieve your data. A day after, you just come and call back your data and put it into the process of the analyze. You start to transform this data into the, let's say, Photoshop, AutoCAD, whatsoever. And at the end, you are bring this, let's say, sheet to studio and show this is my site analysis. It is same as a GIS process. So you need to get some data input, but here we need a geographical database. In here, we are not using number 1, building number 1 is a green, or building number 5 is a blue. We are not work like this. Each of the building or each of the, let's say, object in the world have a spatial reference. So we can refer to that one. So let's now go from this diagram. We have data input, we put it in the geographical database. Then we have some query input. What is a query? Every day again, you are working with a query. You just go to the Google, you write something and ask something from Google. This is a query. This query now go to the geographical database. For instance, you ask from the GIS how many buildings we have. As a query, it is very quickly go and analyze and tell you we have 1,000, let's say 500 buildings here. So this is very simple query. So after that, you start to transform your data and give analyze, and then send it as a display. You show it in a, let's say, computer or picture or poster, like this one. We have it here. This is the output of the GIS as a poster. Let's come back here. We done this. So if you want to say a GIS is a linear process from a data input, data management, manipulation, analysis, and output, but each of these processes have value. 80% of here is data. If we don't have data, it's, let's say, 0. We are nothing to do. We cannot do anything. So we need to have data. 80% is data. 15% is our effort. It means that a management, manipulation, or analyze. At the end, we just gave this 5%. This 5% is important. You just bring this 5% to the output. But everything is this one. If you don't have this 80%, nothing to show. let's go here. We are, yes, here we go. Yes, we have many different methods. Where should I put this one? Let's now put it. Okay, let's put it here. We have many methods for calculation. This is a GIS actually, as you say here, 80% is a data. So we have many kind of the data. We have a hard copy data like a map, table, list. We have digital form like interchange format, GPS, internet, survey measurement, photogrammetry, etc., etc. All of these data coming to this storage. After that, we start to analyze different things, and we send output as a map, as a list, or hard copy, or in a soft copy. So we have 6 methods to collect a data in a real world. In a, let's say, if you want to do something professionally, if you want to gather data, you will have a 6 method of the data gathering. One of them is a GPS or global positioning system. You just have your GPS in your hand and go to the site. It is like the things that you do on the map. You say number 1 is this one, number 8 is that one. But instead of this writing, you just put it everything in GPS. This is the more reliable and easiest, let's say, manner of the data collection. We have a digitalization. You can digitalize by your hand. You can do it, we will come in what is a raster or what is a rector. Don't worry about these terms inside the parentheses. So we will go into that. You can digitalize it. One of the digitalization that you do it, maybe, I can say, for instance, they gave you a map in an A4 piece of paper. You just scan it and then go through the line. This is a digitalization. We have a remote sensing. Remote sensing, it's used by satellite or sometimes UAV or drone. So remote sensing, by use of satellite, you are gathering the data through the world or whatsoever. We have a photogrammetry or aerial photography, which is they capture the high resolution images over the world, and after that they just start to overlap them and make a map. This is called photogrammetry. We have a scanner, the big scanner one that you can scan the old map and again make it digitalized and work with it. And we have a field survey or cadastral surveying, which is the more technical one. So this is about our geographical data collection method. So now after that, we are start to say why we need a GIS. Maybe some of you still have some clue about it, but let's say you want to invest in, I'm just give an example in Famagusta because it is most of you know, all of you. Imagine you are a investment. You want to make an investment or you want to invest some money in Famagusta. Let's say you want to open a shop, a grocery shop or supermarket. So where you are going to open it? If you just pass from a Salamis Road or in a Dow Square or EMU Square, in front of EMU, you will saw a bunch of supermarkets. Many supermarkets locate there. Everyone thinks that if we bring our supermarket there, it's a win-win job because we have many students there. Of course, somehow it's right. But since we have 10 supermarkets there, it means that the money or this cake share with the 10 people. So, which is wrong. You need to find where in a Famagusta have a more population and less market. This is a good place to invest your supermarket. So maybe it is in, I don't know, Dumlupınar or Çanakkale. We have a density of people, but there is no supermarket there. However, in front of EMU, it is just a seasonal in the fall semester and the spring semester student there. After that, no student. For instance, in a COVID pandemic, now no student. This is GIS work. For instance, you want to open an exchange office. You want to open an exchange office in anywhere. So you need to find again same criteria for it. Or imagine, let's go in another type of the problem. For instance, you want to escort some diplomat from Ercan Airport to the, let's say, parliament of the TRNC in Lefkoşa. You need to find a fast and safe way. So with GIS, you are able to do it. Otherwise, the things that happened for John F. Kennedy, so it's happened. So also you want to, in a military, you want to, in a war, you want to know best place for a helicopter landing. So again, with the GIS data, you are able to support this, let's say, problem, or you can make a decision. Or for architecture, you want to invest again, or you want to start build something. With use of this, you are able to do it. So there are many things can be done. About the crime town, you want to the crime location. With GIS, again, you are able to do it. So any question up to now, up to moment? Hello?
I don't think so, no.
Huh, I think so. So that's fine. Everything is clear, I hope. Let's go to the GIS. Now I am giving you the one of the example about the GIS. Actually, we can say that this person, this man, which his name is Jon Snow. I think Jon Snow also someone in one of this movie or game. I don't know, because when first time 3 or 4 years ago, when I'm talking about Jon Snow, some of students say it is a game, the person is there. I don't know that. Anyway, this person is the first user of the GIS, we can say, about this person. For the first time, this person solved the cholera outbreak in London. Actually, he didn't know that he's a GIS user, but he used a GIS somehow in 1850s. So what's the problem that time? As you can follow here, this is a London, let's say, map. We have, as you can see, we have several water pump. This blue dots, the big blue dots, is a pump, a water pump. And this red small dot, which is a bit dense here at the center, is a dead case from the cholera inside the London. This man, this Jon Snow, take a map and put the pump location on the map, and also gather information about the people who die because of the cholera on the map again. At the end of the day, he just started to think that all the case is around this center, let's say pump, next to this one. So he say definitely this pump have a problem, which is which is transmit the polluted water to the people. So he start to close this one. Also, with this hypothesis, he start to convince that the people, cholera, it is not coming from the air. It is coming by water. So he closed this one, this center one, and the problem is solved. So this is the first user of the GIS. He used that time, but he didn't know that what is a GIS. So the logic of GIS is like this one. So as I tell you, let's coming to the application of GIS. We have many discipline which is involved with GIS. For instance, if we are thinking about application area, public administration, planning, geology, mineral exploration, forestry, site selection. This is about, as you say, architecture. I give just two of these examples. Marketing, civil engineering, criminal justice, or surveying. These are just part of the application. We have geography related, like cartography, geodesy, photogrammetry, landform, or spatial statistics. So this is related to the geography. So those who are in a geography discipline, they can involve with GIS. We have also computer science management, which is about graphics, visualization, database management, system administration, security, network administration, cloud, all the things related to computer. So also can be involved. So different discipline could be involved with GIS. So if you want to talk briefly about the application, we can use for earthquake, soil, forest, infrastructure, population, transportation, tax, mine, crime, tourism, about the even legalization inside the city. So you can shape the city information system. For instance, one of the things that it's an interactive map or campus map in EMU. Maybe some of you saw it, or maybe you didn't saw it yet. There is a map inside the university online map. If you just go to the website, if you just click on the building, the information coming, for instance, number of the class name. For instance, as an instructor, when I was an instructor, actually I'm still instructor. For instance, sometimes they gave me, you have a course in, I don't know, ELC something. I'm just always, where is it? And at that time, I start to see there's a map there. So interactive map, I'm going to use that one and find my way. So you can make a forest information system, highway information system, land information system, and many other things. And here we have, as you see, campus information system. So, as I said, again, these are the same repetition. You can use it in a government, state government, business, military, and defense, and scientific research. I'm not going to go over it because it is same thing. Again, as you can see, this is a city information map. This is for Famagusta. I don't know, it still is active. It is developed by Giancaro for Famagusta Municipality. If you just click on each of the building, the area of the plot or land and the picture of the building will coming and appear in front of you. Same thing, this is for a pipeline, again, for Famagusta. So for a city or for a planner for architecture, we can use for a city information system, illegal containment inspection or gecekondu, numerical addressing management, numbering of post, or this kind of things. For instance, in a Famagusta, we don't have a numerical addressing. If you want to travel from some spot to another spot, you need to explain. For instance, if you want to go, I don't know, from EMU to, let's say, I'm just give example, I'm not sure about it even, Uzun 22. Maybe taxi driver is now good know about where is it, but in a reality, when you say to your friend Uzun 22, you don't know where is Uzun 22. So you need to start to give an imaginary map to your friend. Yes, you need to go towards the İş Bankası, and before the İş Bankası there is a road behind. You can turn that road and then go see a yellow building. At behind of this yellow building you find Uzun 22. So, but this is not a reality. We need a numerical addressing management, like let's say America. We just say, I don't know, let's say Illinois number 22. So they just find with this number, they just find where is the location. We have infrastructure management. Let's give also example of this one, which is work also for Famagusta. I'm just saw it many times in a city. For instance, they just come today, let's just example, to dig a street, and then one of the, let's say this building wants a traffic or electric connection. They just dig electric line and put it, and the day after it, municipality come, record the road. Week after, same place, dig it, and the water pipe go. So it means that there is no infrastructure management there. So if there is a system, they do it in one day. It's infrastructure management system, which is done by GIS very easily. Again, about urban information management, which is about developing the city. So, but if we come to the GIS after the application, when we talk about the component of the GIS, we have 5 important components in front of GIS. We have a hardware, which is any piece of tangible of the computer, like a monitor, mouse, keyboard, network card, or whatsoever. These are hardware. We always need hardware for working with GIS. We need also software. What is a software? Including any operation system, any program, any plugin, or any intangible part of the, let's say, computer. We need people. The people are involved with everything. Some of them develop software, some of them maintain the hardware, some of them gathering the data, some of them working with the method to analyze the data, some of them maintain the system. So we need different people and different professional people here. So we need data. We need to collect the data. If we don't have data, it means that nothing works. So we need to have a different sort of data, and we need to have a different method. So the method is a way that you can compile the data, and at the end of the day, coming with the outcome. So as I said, it is an explanation of the same thing. Hardware is a computer, which is GIS operator today put their software and run with use of wide range of the hardware. So this is any part of a tangible piece of the computer. It can be standalone, it can be network configuration, it can be a desktop, or etc. We have also software, GIS software. Different software provide different function or different set of tools for different bunch of the job. For instance, storing the data, analyze them, displaying. We have also other software, for instance, the protocol of the TCP/IP, or we have operation system like Mac OS, Windows, Debian. We have also different GIS application like ArcGIS, the ones that we are going to use. We have QGIS, UDIC. There are different programs. And also there are some script or plugin which can be, let's say, automatic some of the job or controlling some of the behavior in system program. So we have two software type. It is not about GIS, it's about everywhere. We have a commercial software like the ones that you need to buy the license and use it. Or like a global mapper like ArcGIS, Hexagon, Geomedia, and many other. And we have an open source like UDIG, like OpenJam, like Quantum GIS, QGIS, Grass, Map Window, and there are many other. Yeah, I just put a few of them. What is the difference between these two? The commercial software, you know, that always is the most popular one. For instance, AutoCAD, you know, it's a very popular one, but JustCAD, there is also a program which is open source, it is JustCAD, maybe you didn't hear about it even. So this is not a popular one. Commercial software almost redevelop, update, for instance, every year the new version of the AutoCAD or GIS published. You have a professional or technical support which can only given by a seller company. No individual can give you a technical support. And the commercial software, most of them like a closed box. You cannot change the content of the program, or you cannot change the component of the program. It is come as it is. You are going to use as it is. You cannot, for instance, change the, let's say, the component of the program. So, or you cannot combine a new comment on it. Also, a decision and a strategy of the program produced by a company. So the participant maybe can have a very narrow influence on it, what a strategy, but the main strategy done by the company owner. So what about the open source? The open source is open for everyone. You can get open source and change it, the source, and develop your own GIS program, and let's call it Lion GIS. You just find the open source and start to redevelop according to your need. So in this case, most of the time, and not most of the time, always user developer going to collaborate through the forum or internet. They are going to talk and solve their problem. So there is not a specific or responsible company, because personal people redevelop or reorganize the program. It is less complex because the structure developed by user and everything is open. It is not like a commercial one. As a else involved. Any question up to now? Hello.
I think no, John. Everything is clear.
Okay, I think Neriman, because I can't see.
Nur
So,
Hoca.
Noor. Okay, sorry, because I just see N. I just Excuse me. So I'm explaining about the people. We need different people, and we need different administration, analyze, database, data processing specialists. These are the people. We also need different method for data management, human resource, financial resource management, quality management, risk management, time management, and even management of the different standard which is involved in our QGIS. So I think I don't know. This is actually, let's say we have, how many slides we have? Yes, this is, I think, enough for today, because this, let's say, last 10 slide, it is more about the things that we are going to use. I think it is better to stop here. I don't know what's your idea. We just explain what is a GIS and component and different part of the GIS. We are going to use, we are going to start to see how GIS work. We have a few slides more, and then we are able also to go to work with a user interface of the program. I don't know what's your idea about it. And see you next week. Not see you. I hope have a next meeting here, and have a good weekend for you.